Find greatest integer, right? So हमने कहा let question number 33 you have let integer be x, integer be x. So what problem you have? It's very simple. Is such that if 7 is added to its double, so double of this number will be 2x. And when 7 is added to this, 7 is added to this, the resulting number becomes greater than 3 times of the integer. So it is greater than 3 times of the integer, that is equal to 3x. नहीं, लेकिन मैंने करेक्ट कर दिया था बाद में। तुम उस वीडियो को देखना, उसमें बाद में मैंने करेक्ट कर दिया था, वरना वो गणित मतलब वो बैठते ही नहीं सीक्वेंस, राइट? तो मतलब double of it when 7 is added to double of integer, then resulting number this is then resulting number is greater than greater than greater than 3 times 3 times of integer. So it will be like this. Now now you transpose this 2x on this side, so you get 7 is greater than 3x minus 2x. So 7 is greater than x, right? Since belongs to integer, since x is less than 7, x is less than 7, and x is less than 7, and x belongs to integer, right? So solution set will be 6, 5, 4, 3, 2, 1, 0, minus 1, and so on. So infinite, since it is integer, so on left side it is infinite, left side it is infinite, and here it is so the large, so greatest integer will be, among these greatest integer is 6, greatest integer is 6. So greatest integer is 6. Now it is clear. So you should ask to me now. If you have, you can ask n number of times. Don't ask him. ठीक है ना? You have noted this? Oh. done. Fine. Should I rub? Now we will talk about. Now we are studying chemistry, and chemistry, that is, we are going to talk about chemical bonding. Chemical bonding, right? Okay. Can you tell me why why elements elements undergo undergo a chemical reaction? So why elements undergo a chemical reaction? Can you tell me this? What is the benefit of getting new product? That element will get what benefit? Anyway, anyway, elements undergo undergo a chemical reaction to complete their octet or duplet or or to get stable stable configuration of nearby nearby inert gas inert gas inert gas, right? Wait. So elements undergo a chemical reaction to complete their octet or duplet or to get stable configuration of nearby inert gas, right? Okay. Can you give me a cup of coffee? Okay. Yeah. This is this activity occurs by two methods. मतलब this ये to get this stable configuration of nearby inert gas or to complete their octet or duplet, there are two ways, right? What are those? First is first is first is first is transfer of electrons. Transfer of electrons. Transfer of electrons. Right? It is called electrovalency. Electrovalency or electrovalent compound. Electrovalent valent compound, right? Electrovalent compound. This is transfer of electrons. Like if we talk about, you know, if we talk about, there is sodium. Sodium electronic, it's in its inner shell, two electrons, middle shell, there is eight electrons, right? Eight electrons, and in outermost shell, it is having one electron, right? It loses one electron, get positive charge, get positive charge, get positive charge, and that is Na plus, and its electronic configuration is 2,8 now, right? Similar, similarly, chlorine is having seven electrons. Chlorine is having atomic number 17. So in first shell it is having two electrons. In second, it is having eight electrons, and then it is having seven electrons. So one, two, three, four, five, six, seven. And this one electron it adopts. This one electron it takes. When it takes one electron, get negative charge. Gets negative charge. Negative charge, and then it is getting electronic configuration. We say it's Cl 1 minus, electronic configuration 288. Now they are stable, right? Sodium is having Na plus 288, Cl is having 1 minus 288, sodium is having 28 and chlorine is having 288. So both are having in stable condition. Now they combine together. Now they combine together and form Na1 plus Cl 1 minus. This is sodium chloride. Sodium chloride. Sodium chloride. And this is a electrovalent compound. What? It is electrovalent compound. Okay. And since it is electrovalent compound, so its mass is known as formula mass. Its mass is formula mass. We called it formula mass, right? Electrovalent compound is having formula mass, and and other is having molecular mass. Okay. So should I rub this? So this is first we talk about by sharing of electron, by transfer of electron, right? Okay. Like if we talk about magnesium, magnesium is having electronic configuration 2A2. So in case of magnesium, in inner shell there is 2 electrons. In middle shell there are 8 electrons. 8 electrons, right? And in outermost shell it is 2 electrons. It has 2 electrons, right? So, so to attain the stable configuration, it loses these 2 electrons. Loses loses 2 electrons, right? This is electron one. This is electron two, right? And it gets electronic configuration of 2 8, right? And now it is having Mg 2 plus, right? Now it is in a stable condition. If we talk about again here chlorine, so chlorine is having 7 electrons in its outermost shell, right? And here it is. Now what happens? It takes 1 electron from it takes 1 electron this and get 288, and it is getting Cl1 minus 1 minus, right? And similarly, this electron goes to here and it becomes stable. It gets electronic configuration of 288 and Cl1 minus. So now what happens? Now magnesium with 2 positive charge, 2Cl1 minus, right? This is ionic compound which we read it MgCl2 like this. But it is like this. But it is like this. It is ionic compound, so they have this kind of attraction. Since in ionic compounds, since in ionic compounds electrostatic electrostatic force of attraction force, so strong bonding, so strong bonding, right? High melting and boiling point, melting and boiling point, and high ionization potential. What? They have high ionization potential, high ionization potential. Yeah. How it can be when they are strong bonds, strong electrostatic bonds, right? In aqueous solution, they break down into their ions. So in aqueous solution, they have low ionization potential, right? Electron, then when they are ionization potential, actually exchange of electron. What I said, he, in normal condition they have high ionization potential. But if you make their aqueous solution, they convert into they change into ions. When they change it into ions, so they need less ionization. In aqueous solution, they need low ionization potential. In, and generally, when you dissolve this magnesium chloride in water, it get dissolved. And when it get dissolved, then sodium ion goes, separated from chloride ion. So in aqueous solution, in aqueous solution, they easily break into ions, into their respective ions. So in aqueous solution, they have low ionization potential. Low ionization potential. ठीक है? अभी क्लियर? अगर aqueous solution में नहीं है, then they need high ionization potential. Then, but since they are basically water soluble. All sodium chloride, magnesium chloride, calcium chloride, right? Calcium carbonate. They all are water soluble. When they are water soluble, so in aqueous solution they convert into their ions, and when they convert into ion, it means their ionization potential is less. Getting? So should I rub this? If we talk about you know calcium carbonate, calcium carbonate. So calcium is having valency. Calcium is having atomic number 2882, right? And carbonate is having 2 units negative charge, right? 2 unit negative charge, right? As a whole. So what they do, they are negatively charged, and when it loses two electrons, it becomes 288, right? It becomes calcium ion, right? 2 unit charge it is having, plus 2 unit charge it lost. So it gets 2 unit positive charge, and it is having, carbonate is having 2 unit negative charge. So they combine together and form, you know, ionic calcium carbonate. In aqueous solution, In aqueous solution, in aqueous solution, they convert into their respective ions, Ca plus, Ca2 plus, and CO3 2 minus, right? Then ionization potential is low in aqueous solution. Ready? So this is what we have by transferring of electron. One is giving, another one is taking, right? So this is, we have calcium carbonate, and similarly there are many more, right? Again, now we come to another type of bond. Should I write this? Yeah. Now another way to get stable configuration, another way to get stable configuration, another way to get stable configuration of configuration, right? By sharing of electron, sharing of electron. So no one is giving to anyone, no electron is exchanged, just they share between each other, right? If we take in consideration hydrogen atom, it is having one electron in its outermost shell, and how this hydrogen atom is having one electron, right? So what they do, this hydrogen atom takes one electron from this and complete its duplet, and this hydrogen atom takes electron from this and complete its duplet. So between hydrogen and hydrogen atom, there is single bond, single bond, right? And 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 no lone pairs, no lone pairs with both. So charge density, electron charge density, electron charge density is same, right? They have, मतलब दोनों के पास इलेक्ट्रॉन लोन पेयर नहीं है, तो इनकी इलेक्ट्रॉन चार्ज डेंसिटी सेम है. तो जो जो शेयर्ड इलेक्ट्रॉन पेयर होगा, ये जो हमारा शेयर्ड इलेक्ट्रॉन पेयर है, that is this is called shared electron pair. This is shared electron pair, shared electron pair. It is in center. It is in center, right? In center, and no partial charge develops, and no partial charge develops, right? That's why, since no partial charge develop and no and electron charge density on both the atom is same, so they form नॉन पोलर कोवैलेंट बॉन्ड्स, इनको बोलते हैं नॉन पोलर कोवैलेंट बॉन्ड। नॉन पोलर कोवैलेंट बॉन्ड्स, कोवैलेंट बॉन्ड्स, राइट। व्हाट इज ए केमिकल बॉन्ड? केमिकल बॉन्ड इज फॉर्म्ड, केमिकल बॉन्ड, केमिकल बॉन्ड is formed by by sharing of two electrons which comes from two different atoms, two different atoms. Getting my point? Chemical bond is formed by sharing of electrons which comes from two different atoms, right? This point you keep in consideration and always keep in mind. In covalent bonds, the chemical bond is formed by sharing of electrons, where electron comes from two different atoms, right? And atoms. Or since both the atoms are having same electron charge density, so a shared electron pair is in center and no polarity develops. That's why it is known as non-polar covalent bond. In hydrogen there is single bond, right? Should I rub this? If you have any problem in writing, na better you concentrate in understanding. I'll send you the video, then you make the notes. Because I have a flow, so I keep on speaking, and after when I finish the class, I'll send you the video, then you make your notes according to that, right? And small things. This thing you should keep in mind. Yes, this you make a note. कि ये अभी हम आगे पढ़ेंगे तो इसका काउंटर आएगा, that's why I am saying, right? So this is we have, and you understand this. Okay, now another example. Should I have this? Going to run, or you can take a screenshot also. Anyway, this is I rubbed, but the next time if you're not able to read screenshot लेंगे है ना, good. अभी क्या है, second we take, say there is oxygen atom. Oxygen is having, 6 electrons in its outermost shell, right? And there is another oxygen atom which is having 6 electrons in its outermost shell, right? So what happens? This oxygen atom takes 2 electrons from this oxygen atom and complete its octet, and this oxygen atom takes an electron from this carbon atom, this oxygen atom, and completes its octet, right? They both, this is one chemical bond, this is double bond. They form two chemical bonds. There is O, double bond O, right? But and both atoms, this is, this is we call, this we call This is called, this is also known as, this we call lone pairs. Lone pairs, right? Lone pairs, मतलब pair of electrons, pairs of pairs of electron not taking part, not taking part, taking part in bond formation. In bond formation, ठीक है? Bond formation. So they are lone pairs, pairs of electron not take part in bond, not taking part in bond formation, and this is shared electron pair, shared electron pair, right? Uh, for bond formation, for bond formation, right? One chemical bond, one chemical bond, chemical bond has two electrons which comes from two different atoms, right? And both the side electron charge density is same. Both atoms have two lone pairs. Here is also two lone pairs, right? And here also it is two lone pairs. So both are having same lone pairs. So both atom both atom have same electron charge density, same electron charge density. So polarity does not develops, right? That's why they are known as, इनको हम बोलते हैं नॉन पोलर कोवैलेंट बॉन्ड्स. नॉन पोलर कोवैलेंट बॉन्ड, ठीक. Here is double bond. In hydrogen there was single bond. In between oxygen, double bond. Should I rub this? Take a picture of this. Okay. Okay. I'm going to rub. Right. Now we have one more very classical element that is known as nitrogen. Heard about nitrogen? It is having 5 electrons in its outermost shell, right? This is. So this nitrogen atom takes 3 electrons from this atom and get the stable configuration of 8, right? 6 plus 2 becomes 8. And this nitrogen atom takes electron and get the stable configuration of 8. Right? And here is one chemical bond, second chemical bond, and third chemical bond. Right? Three, three, three pair of shared, three shared electron pair. Three shared electron pair. So three chemical bonds. Three chemical bonds. Right? Oh, chemical bonds. Each atom has one lone pair. Each atom of nitrogen has one lone pair of electron. One lone pair. One lone pair. So electron charge density, electron charge density is same, right? No polarity develops. Getting? No polarity develops, and that's why it is also an example of non-polar covalent bonds. Non-polar covalent covalent bond. So generally non-polar covalent bonds, non-polar covalent bonds, covalent bonds formed between same type of molecules. Same type of molecules. Getting? So, so in all, if we see what oxygen, oxygen is having hydrogen is having single bond, hydrogen atom single bond, oxygen atom double bond, nitrogen atom having triple bond, and they all are having electron charge density same, so they are non-polar, right? Okay, should I rub this? Okay, so again we have one more type of, so we have studied electrovalent bonds, electrovalent bond, then we have non-polar covalent bonds, non-polar covalent bonds. And now, if you take of example of oxygen, oxygen has 6 electrons in their outermost shell, right? And hydrogen is having 1 electron in its outermost shell, right? So, hydrogen takes 1 electron from oxygen and complete its duplet, and this hydrogen atom takes 1 electron from oxygen and completes its duplet, and this oxygen takes each electron from both the hydrogen atoms and complete its octet, right? Now point is that no lone pairs, no lone pairs with hydrogen atoms, right? But oxygen is having, this is one lone pair, this is two lone pair. So oxygen has two lone pairs of electron, two lone pairs of electron, right? So therefore, electron charge density, electron charge density of oxygen is more, right? Therefore, electron charge density of oxygen is more, and shared electron pair slightly slightly moves towards towards oxygen atom, right? So these shared electron pair slightly moves towards oxygen, and develops partial negative charge on oxygen. And since oxygen get partial negative charge, so hydrogen atom get partial positive charge. So therefore, due to difference in due to due to difference in electron charge densities, electron charge densities, and among two atoms, among among oxygen and hydrogen, so polarity develops, right? Therefore, this type of bonding is known as this type of bonding is known as polar covalent bonds. This this bonding this bonding known as polar polar covalent polar covalent bond, right? So another type of bonding is there, that is polar covalent bonds. Polar covalent, sorry, polar covalent bonds, right? I hope you understand this. Okay. Should I rub? Okay. Since between hydrogen and chlorine, difference in electron charge densities are very high, so they can form electrovalent bond as well as they can form covalent bond also, polar covalent bonds, both, right? So if we take chlorine, if we take chlorine, so what happens? It is having 7 electrons in its outermost shell, and oxygen is having, sorry, hydrogen is having only 1 electron. So hydrogen takes 1 electron and get stable. Chlorine takes 1 electron with hydrogen and stable. Right. This is this is shared electron pair. Shared electron pair. So hydrogen no lone pair, and chlorine has 3 lone pairs. 3 lone pairs. Right. So electron charge density of chlorine is more, chlorine 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 is more, so shared electron pair shared electron pair shift towards chlorine atom and get partial negative charge, right? In response of this, So this is shifted towards here, so it gets partial negative charge, and in response of this hydrogen gets positive charge, partial positive charge, right? Partial positive charge. So there is polar covalent bonds, polar covalent covalent bonds formed, right? Polar covalent bonds formed. So polarity is due to difference in electron charge densities. If among two atoms there is difference in electron charge densities, then polarity will develop and polar covalent bonds form, right? And if electron charge density is same, then polarity does not develop and non-polar covalent bonds form, right? I hope you understand. Should I rub this? Okay. Now we have coordinate bonds. Coordinate bonds. Coordinate bonds, they are they are type of type of they are a type of covalent bonds, covalent bonds, but as in covalent bonds, eh, as in covalent bonds for bond formation, bond formation, bond formation, two electrons comes from comes from two different atoms, two different two different atoms, but but in coordinate bond for bond formation, bond formation, both electron comes from comes from one atom only, one atom only. Did you get it? What I said? This is nitrogen atom. It's having 5 electrons in its outermost shell, and there are hydrogen atom, hydrogen atom, hydrogen atom, right? So what happens? Hydrogen take one electron from this nitrogen atom and complete its duplet. This hydrogen atom takes one electron from this and complete its duplet. This hydrogen atom takes one electron from nitrogen and completes its duplet. And nitrogen takes one electron from each atom of hydrogen and complete its duplet. Right? अभी क्या है? It is having ये one lone pair. This is one lone pair. Right? So, and this is shared electron pair. One bond single like this nitrogen, hydrogen, hydrogen, hydrogen. Right? And there is one more hydrogen atom get attached. Right? But for bond formation, both the electrons given by nitrogen. One more, one more, one more hydrogen atom attached, attached, but for bond formation, bond formation, both electrons, both electrons given by nitrogen atom only. So it is a type of, it is coordinate bond. Coordinate bond. Fine. So there is a coordinate bond and it forms NH4 plus 1 plus. It is ammonium ion. Ammonium ion. Right? Since it is having one unit of positive charge, so if chlorine atom get attached with it, chloride ion minus one unit, then they form ammonium chloride. Ammonium chloride. And in ammonium chloride, all type of bonding, all type type of bonding can be seen. How it is? This is this is coordinate bond. This is coordinate bond. This is coordinate bond, right? And these are these are covalent bonds. Covalent bond. And among these two, between this plus and minus, there is this is what electrovalent bond. Electrovalent, electrovalent bond. So you can see all types of bonding in ammonium chloride. I hope you understand. Oh, again. So this much is, I hope. After that there are so many examples, but they are similar to that what I told you in your book, and this is given. Yeah, yeah, this is given. So you just go through with your books, you will find all the things which I discussed. That all the major point I discussed. If anything is left, you told me you will go through with the things. All the conceptual things I told you about chemical bonding, which is required for you, right? And if you find any difficulty in understanding for any other compound which is given in your book, you can ask me freely, right? So for so for so for today, I hope we should call off now.